Hello coders, welcome to my channel Radhe Radhe. Today we are going to cover the lecture 2 of two pointer. Yesterday I have posted the lecture of 1 in which we study about in detail what is two pointer and why we use two pointer approach, and I have discussed two question. First one is a two sum question and second one is the three sum question. uh, and I have give the detailed explanation how to solve this too. Now in today's video we are going to cover the another two question which is solved by using the two pointer approach. The first question is the count pairs whose sum is less than target. You can find this question in the lead code. So uh, so let's understand the statement what is saying. You can see we have given a zero index integer array num of length n and an integer target. We have to return the pair where the sum of both true is smaller than target. It means the sum of the two numbers should be lesser than the target. So this is the question, and we can see the explanation. Uh, Here we have given nums -1, 1, 2, 3, 2, 3, 1. Target is 2. So you can see that there are three pairs to satisfying the condition, this condition. Like if we sum num 0 plus nums 1, it gives us 0, which is lesser than the target value. That is, in this case we have 2. Now another pair is num 0 and nums 2, which is num 0 and nums 2, which is summing and giving us 1, which is again lesser than the target value. Now the third pair has num 0 plus num 4, that which gives you 0, which is again smaller than target value. And the rest of the rest are not be able to satisfy the condition, this condition. So that's why we return the answer 3. In the same way, you can see here 10 pairs are forming. So I think this is the I think you understand what is question actually saying. And if we see the constant is very small, like it's only 50. So we can use the brute force approach here, and our test cases will pass. So how will you use a brute force approach? Simply we will use the two loops, like what I'm saying. Let me explain. Like we have given the array -1, 1, 2, 3, 1. So we can use for loop. We can put the I pointer here and j pointer one step ahead of I. That is here. Now we will move the j pointer in the first case when I is 0. We will make the pair -1 1, -1 2, -1 3, -1 1. In this way, we again move the pointer I when all the elements will be covered. We move the pointer I will be here, j will be here, and again we will do the summing of these two pairs, and we will check if both the sum, that is both the sum is d equals to smaller than target, which is t. I'm taking here. If it is satisfying the condition, then we will do the C++, and then we will return the C++, and this is our final answer. So here I have commented out this because we have to discuss the another approach. So you can see that here is we have given uh, I am taking two loops. For first one is indicating I, second loop is j, which is one step ahead from I, and then I'm plusing both the number and checking it is, if it is smaller than the target, then we will do count plus plus, and then we will return this count. And if you run this code, you will find that all our test cases will pass, because we have given only 10 to 50 as a constant. And we know that the our code will run lesser than or equals to 10 to the power 8 time complexity. So it will follow that condition. That's why all the test cases will be passed. But as a programmer, we know that in our OS and all, we everyone wants the efficient solution. So that's why we are using two pointer approach here, so that our time complexity will be decreased. So if we see the two pointer approach, I will explain how to solve this question with the two pointer. Like first, I taking the question of nums is given as the num that I have given minus 1, 1, 2, 3, and 1. Now, as we have seen that in our next in our previous question that we have discussed yesterday, you can see that in this question, first we have sorted the array. Like if you don't know, if you don't watch my lecture one, you can watch it in my channel. So now you can see that we are sorting the array. In the same way, we will do the same thing here. We will do also the same thing, like we will sort the array. So our array will become minus 1, 1, 1, 2, 3. So yeah, we can first we should sort the array. Array will become minus 1, 1, 1, and 2 and 3, I think. Yes, 2 and 3. Now, as I said in the yesterday lecture, that we will take one pointer here and other pointer will be here. Now it's given that we want the sum which is lesser than the target. Here our target is given 2. So if the target is 2, so we will check that pair whose sum is lesser than the 2. So if we plus minus 1 and 3, it will give 2. So 2 is not lesser than 2 because it is equals to 2. So we can discard this one, and then we will move our pointer. Now how will we move our pointer? As we have seen in yesterday lecture that if the sum will become greater than the target value, we will move the j pointer because we have sorted the array in the descending or in the ascending order. So to make the sum smaller, we will need smaller elements, and we will find the smaller element in the left hand side. That's why we're removing the j pointer by doing j minus minus. Now if we sum the value both of these, we will find 2 minus 1 equals to 1. So we can consider this as our answer 1, answer plus plus. Now again we will but yeah, here we do not do answer plus plus. Here we do another thing. Like if our left is here, right is here, so we will do count equals to right minus left. Count equals to right minus left. Count plus equals to. But why we are taking right minus left instead of doing L answer plus plus? Because uh, okay, I will explain. Like here in our array, minus 1, 1, 1, 2, and 3. Our I pointer is here, our j pointer is here. Yes. So uh, we are doing r minus l. That is r minus l means j minus i. J minus i. I have taken the wrong variable right now. J minus i. So now what is I and j here? It's an indexes, that is 0, 1, 2, 3, 4. So j is 3, l is 0. So if we do 3 minus 0, it gives us 3. It means we have 3 pair in this range which are satisfying the condition. Like you can see that minus 1 1, it is giving 1, minus 1 1, it is giving 0, which is lesser than target, minus 1 1, which is again giving us 0, lesser than our target. So here we have three pairs. So that's why, and you can see by doing r minus n, we are also getting 3, because if our j is here and it is giving some lesser than the target value, it is obvious, or it is a common sense that the another pair, it will plus with the I, it will also give us the target which is smaller than the target, because we have sorted the array in the ascending order, so we will find the smaller element, and the is 2 is smaller than 1, that means 1 is smaller than 2, so if we add, it will also gives us smaller value. That's why we are not just doing a plus plus, we are considering all the pair from this range, because it will gives us the value smaller than the target. That's why we are doing our j minus I. So same way, this is the all about the, this is all the algorithm. Like for more clearance, I will dry run the code. We have given minus 1 1 2 3, minus 1 1, again 1 2 3. Our I is here, our j is here. Now we see that count plus 3, r minus l, we have done 3. Now if we find the value, we will again move the I pointer, because we get our answer. We get our answer, like all the pair from here to here, where the first element is this one. Now we will move the I pointer to make the another pair. So I will be moved the same way we will making the sum. If we find the sum smaller than the target, we will move I plus plus, as we will move j minus minus. So this is the intuition behind my approach. So let's see the code. The same thing I have done in the code as well. Like you can see that first we short the array, short the vector, then taking the L equals to 0, right equals to num psi minus 1, that is starting from the this side. And we taken to store our answer in a variable, we taken count. And now how the breakpoint for this is the when left becomes smaller, when the left is smaller than right, then it will be it will the loop will be run. But if the left become greater than right, then this is the breaking point. Now the same way we have do some summing of the two elements, and if the target is smaller than, if the summing is smaller than target, we simply count the variable with r minus l. And again we do the left plus plus, because I have said there, like if we find all the pair where first element is this, now we again go ahead and we will find all the pair where whose first element is this one. Else, if we find the smaller number, if we find the greater number than target, we are moving the pointer in the left direction. And the same way we have return the count. Now if I submit the code, it will pass all the test case. You can see. So yeah, you can see that all our test cases has passed. Now if we talk about time complexity, you can see there is one short has done, so it will O of n log n, and one loop is running, that is O of n. So O of n log n, because if someone don't know about the complexity of sorting, it is O of n log n. The time complexity of sorting is O of log n log n. Okay, so and we have one loop. We are running one loop, that's O of n. So if we are here, it will be dominate this factor. So this will be removed. Then we will get only this value of n log n. This is because this is bigger. So so the time complexity will be this one. Now if we talk about the space complexity, you can see that we haven't used any extra space. We are just doing the performing any thing with this nums that is given in our question. So the space complexity will be O of 1. So yeah, we have solved the question in this. In this, where for in the brute force, what we have the time complexity, it was O of n square. Now here we can see after doing 2-point approach, our time complexity decreases to O of n log n. So this is the use of 2-pointer. Like to make the program efficient, we use a 2-pointer approach. Now the second question that we have is the another question, that is find the first palindromic string in the array. So you can find this question again in the lead code. In the lead code you can find this question. Okay, so it is a easy question. So it is a easy question. Now the is we run about we will talk about the question. We have given an array of string word. We have to return the first palindromic string in the array. If there is no such string, we have to return the empty string. Now there is a question around arises that what is palindromic string. So palindromic, like it is a string. So palindromic string is like I have taken example A B B A. You can see that if we reverse this in a disorder, if we reverse this array, it will become A B. This will come here. Again, this will come here, and this will be in the last. So you can compare these two array by you can see that both are the same. So it means both are same. So it means it is a palindromic string. Okay, so I think you want to understand what is palindromic. It is the string in which we reverse the string from backside, and what we get, that string will be equals to the initial string. So this is the palindromic string. So our question is saying the same thing, that we have to check the first palindromic string and we have to return only that one, only first. We know if we get the first string, we just need to return and we don't need to see the further string. Okay, so here you can see ABC. Now if we reverse it, it will become C. ABC is given. Now if we reverse it, it will become CBA. Now you can compare both. Both are not equal, so it means it's not a palindromic string. So we will move our pointer. We will move ourselves to other character other string, that is car. We will again see that the car is also not a palindromic string, but now ADA. ADA, if we make its reverse, so ADA will become, if we make its reverse, so it will become ADA again. And if we compare both, you can see that both are palindromic because both are same. So that's why ADA is returned here. Now again, if we see not a palindrome and race car, if we make its reverse, it will not give the same thing. But if we make the reverse of race car, like you can see, we have given race car. If we make a reverse it will R A will come, C will come, E will come, C will come, A will come, and R will come. Now if we compare, both are the same. So that's why it is a palindromic string, and that's why this is one the first we get, and so we return the answer. Now here we see DEF. If we reverse it, it will become FED, which is not palindromic. If we do the reverse of GHI, it become IHJ, which is again a not palindromic string. So we are returning the empty string, because in the question you can see it is given that if we are not getting any string, we have to return the empty string. And if we see it's a constant, it's a very small, just 100. So if we do the brute force approach, we can, like, if in the brute force we will run two loop and check the palindrome, so it will pass the all the test cases. Okay, so now with the help of 2-pointer, how it will be solved, I show you. First we will take the array. Array is given ABC. CAB, ADA, race car, and cool. Now we'll keep the track of all the word. We will first make a one for loop. Which will really track all the pointer ABC, CBA, and the rest all. So we are making one for loop. Now after that, now we will check each string one by one. So I have taken first string in a name of variable, an variable, will be word I. Now again we are doing the same thing that we have done in the rest of the question that we have discussed already. J equals to and k equals to a of n length minus 1. You can take I or j as well, but here I already taken the I, that's why I have taken j and k. Now in the same way we are making j smaller than equals to k, okay, and I'm checking that if a of j not equals to a of k, so to keep the track I'm making one variable f to keep the track that is if it is not a palindrome, so again we will break the loop. We will break the loop and check if the f equals to 1, that is the loop haven't entered in this condition, then it is a palindromic string, then we will return that answer, that is string. So it's dry. If we do the dry if we do a dry run, what it means that we have given, let me take the smaller one, df and ghhi. I will change this to any palindrome. We have ded, like let's say ded is given and ghi is given, or else like def okay, and ded is here. Now the first pointer will keep the track of all the elements. So it will first will be I is here. Now in this high, our string a and will become this one, and we will take I is j is here, k is here, and check if j not equals to k. So it means it's not a palindrome, because we know that the if we are reversing, so these two will be same for the palindromic condition. So just the same thing I am doing, like making checking and same, and I have discussed. Like you can see, we have given a race car. So j pointer will be here, k pointer will be here. So you can see in the palindrome, r, j and k are same. A and this one is same. This one is same, and this is the middle one. This is same. This is there is no need for that. So it means to make the any string palindromic, the first half will be equals to the second half. That's why I'm taking I, j is here, k is here, and moving k is side and j is this side, and checking. So this is a simple thing I have done here. So if we talk about the time complexity, you can see that here O of n is taking the length of the, let's consider length of the whole word is O of n, and here O of m is taking, let's consider the m is the length of the but each string. So we can see the loop is inside, one loop is inside the one loop, so it will be become O of n into m, because one loop is inside the another loop. So it will be O n into m, and our test cases will be passed because the palindromic because the constraints are very small. And if we talk about the time complexity, you can see we are just taking one string to return the answer. Then you can also avoid that also, but yeah, if you're taking, so it will be O of n. O of n is a time complexity, because we are taking one string to store the answer. Now if we run the code, you can see our all the test case will be passed. So yeah, you can see that our test cases are passed. So yeah, in this way we can solve this question also by using the two-pointer approach. So these two are the question that I had discussed today. Now now in the next lecture I will provide some another questions with of different pattern, so that you will get the idea and get the concept will be clear for the two-pointer. Um, So, if you like my video, please like, share, and subscribe. Thank you.